All right, let's talk about something you use pretty much every second you're online. From the shows you stream to the groceries you order, nearly everything is powered by this incredible technology called cloud-native computing. But have you ever wondered how this massive digital world is actually kept safe? Well, today, we're going to pull back that curtain. Let's get right into it.
So what in the world is cloud native? In simple terms, it's just a way of building and running apps so they can really take advantage of everything the cloud has to offer. So instead of one giant, clunky program, you break it down into these tiny little pieces called microservices. Each one gets its own little box, a container, and then a system, usually Kubernetes, acts like the conductor of an orchestra, telling all those little boxes where to go and how to talk to each other. It's the engine that makes the world's biggest services run so smoothly.
And yeah, that right there brings us to the million-dollar question. If our entire digital lives are built on this super complex, interconnected web of containers and services, how on earth do we keep it all secure? How do you defend something that's always moving, always changing? That's the puzzle we're going to solve today. Thankfully, we don't have to reinvent the wheel. There's this absolutely brilliant mental model to help us make sense of it all. It's known as the 4 C's of cloud-native security. Just think of it as our blueprint for building a digital fortress, one protective layer at a time. It takes a really complex topic and makes it something we can all actually talk about and understand.
So here they are, the 4 layers. It all starts with the cloud. That's the ground itself, the physical foundation our fortress is built on. Then you've got the cluster. Think of this as the fortress walls, the gates, the whole perimeter. Inside those walls, you find the containers. These are like the individual rooms where the applications actually live. And finally, deep inside those rooms, you have the code. That's the actual activity happening. And you've got to have security on every single level.
Now, check this out. This chart tells a really important story about where the focus is. Turns out, securing the Kubernetes cluster and just understanding the security fundamentals, each one makes up 22% of the knowledge you need. That's almost half the battle right there. So what does that tell you? It tells you that if you want to secure the whole system, you have to start at the control center. So let's zoom in right there on the cluster.
Okay, so this brings us to the heart of the matter, the Kubernetes cluster. This thing is the brain of the entire operation. Seriously, it decides where every single container runs, how they talk to each other, and who gets access to what. If an attacker gets control of the cluster, well, it's game over. They control everything. Securing this layer isn't just important, it's non-negotiable.
Now, inside that cluster, there are a bunch of key parts. But for security, there are 2 you absolutely have to know. First is the API server. It is the main gatekeeper. Every single request to do anything in the cluster has to go through it first. The other one is etcd. You can think of etcd as the cluster's secret vault. It holds all the configuration, all the secrets. It's incredibly sensitive, so protecting it is priority number 1.
So when we're securing that main gatekeeper, it really comes down to 2 big ideas. First up is authentication. This is basically you proving who you are, right? Showing your ID at the gate. But once you're in, you still need access to sensitive stuff like passwords. That's where secrets management comes in. It's the system for securely handing you the keys to only the specific rooms you're actually allowed to be in.
But listen, good security doesn't just stop at the front door. A really smart defender builds walls inside the fortress too. We call this isolation. And by using something called network policies, we can create these little mini firewalls between our applications. So what happens if one container gets compromised? Well, the attacker's trapped. They can't just wander around the rest of the system. It's a beautiful example of what we call defense in depth.
Okay, so we've got the running system locked down. But what about all the parts we used to build it in the first place? Security doesn't just start when the app goes live. No way. It has to start way earlier. We need to secure the entire digital supply chain, from the very first line of code or developer writes all the way to the final product that gets deployed.
It's a lot like a physical supply chain, right? You have to trust where your parts are coming from. In our world, that means securing the image repository. That's the warehouse where all your software components are stored. It means checking the integrity of every single piece to make sure it hasn't been tampered with. It means making sure you have compliance and rules every step of the way. And it all starts with using trusted images from day one. If even one link in that chain is weak, you just can't trust the final product.
So we spent all this time building our defenses, but what are we actually defending against? You have to understand what the attacker wants to do if you're going to stop them. So let's take a quick look at the most common threats that are out there right now.
First up, you've got the classic denial of service.
This is just brute force. The whole goal here is to just flood the system with so much junk traffic that it completely grinds to a halt and becomes useless for real users. Think of it like 1,000 fake customers creating a massive line so the real ones can't get in the door.
Next is something way more sneaky and, honestly, way more dangerous: privilege escalation. This is where an attacker finds just one tiny crack to get a small foothold. From there, they work to escalate their permissions, moving up the ladder, grabbing more and more control until, bam, they have the keys to the entire kingdom. They've become the administrator.
And that usually leads right to an attacker's ultimate goal: malicious code execution. This is the end game. This is when they've gained enough power to run their own nasty software right on your systems. And that could be anything: ransomware, crypto miners that steal your resources, you name it. But here's the really cool part. The defenses we've been talking about, they map directly to these threats. You've got an attacker snooping around on the network? Boom! That's where network policies come in and trap them. They're trying to get at sensitive data? Nope. Strong secrets management is the shield for that. And if an application itself gets compromised, that's where pod security standards act like a leash, limiting what a bad application can do and containing the damage right then and there. See, there's a defense for every type of attack.
I know, it can feel like a lot to take in, but at the end of the day, it all comes back to this one number: 4. The 4 C's: cloud, cluster, container, and code. If you can just remember that simple layered model, you'll have an incredibly powerful way to think about one of the biggest security challenges we face today.
And that really just leaves us with one final thought to chew on. We've built this amazing world that completely runs on this dynamic, powerful technology. The big question we all need to keep asking is this: is our security thinking evolving fast enough to actually protect it? Thanks for tuning in.